Okay, I believe it should be streaming. So hello, my name is Aidan Andrews. I'm a third-year physics student at the University of Illinois Urbana-Champaign, and I do AI research. Today, I'm going to be taking two approaches to this kind of region of interest, chain of thought reasoning for vision-centric tasks. So the first approach is going to be just to re-implement this entire paper that I've been made aware of by one of my professors. And then my second approach is this thing that I made up and I kind of thought of for the startup that I'm working at, and just generally for a couple of projects that I'm working on. But kind of re-implementing the same thing, but leveraging these really, really heavy pre-trained LLMs instead of, or multimodal LLMs, which is what MLLM stands for. So the second approach, I imagine, might yield better results than the first approach, but I did want to implement ARGUS from scratch just for like my own personal reasons, I guess. I don't know why I can't really articulate that well this morning, but it's currently 7:43 a.m. It's the third day of spring break, so I've been taking it pretty easy the last 2 days, and then I just got bored, so I was thinking today I'll just do this. Just some research stuff. What's your cursor theme? I don't really know. Just light mode. So yeah, I'm not gonna do any music today. Like no music in the background of the stream, because I'm probably gonna be talking quite a bit. But yeah, I was just bored over winter break, or not winter break, spring break. And so here we are. Rising grind indeed. What's the word? All right, so I've already pretty much read this entire paper. I know what they do for the most part. So the biggest difference between the two implementations that I'm going to be doing is the first one actually natively works in the embedding space of the whatever model I'm leveraging. I'm probably going to use some Qwen variant or something. And then the second approach doesn't touch the underlying models at all. I mean, the first approach, I'm not going to do a full fine-tuning, because they do some fine-tuning where they get they fine-tune the model to give them some region of interest, like the VLM itself. I was just going to use some grounded VLM that already outputs bounding boxes, and then re-embed that and include that as context for the original query. But they do something like this, it's literally in the paper actually. I don't really have to. Thank you. But you get some sort of pixels like this, or some location in the image, ... and then you have your ending, right? So I'm not gonna actually fine tune to get these outputs. I'm just gonna leverage some pre-existing model. So the first thing I need to do is get the data set, which I kind of already looked at. Let me get this link over here. I have 1 billion monitors, so if I'm looking in all sorts of different directions, that's why. So I'm going to use this data set. It comes with bounding boxes, questions, answers, the original images. So it should be a really rich data set to use for this example. So I'm just going to download it from Hugging Face, and I already have the command actually. So that will give me the full data set. I actually have never worked with this data set before, so loading it might be like non-trivial because I don't really know how to do it yet. But you can see some of the examples here. Right, what appliance is to the right of the cabinet? So the whole point of this is like standard MLLMs, like multimodal LLMs, would really struggle with this question, right? We see the appliance is here, but multimodal LLM doesn't like natively know to introspect, I guess is the best word, into certain parts of the image. Instead, it would just look at the entire image and all the pixels and try to make some sort of guess. But with region of interest, chain of thought reasoning, the idea is you get some sort of region, you get the region from bounding boxes, you add maybe some padding just for safety, and then you upload that cropped image as context as well, so that the VLM or whatever pre-trained multimodal LLM you're using can leverage the new region of interest in context when answering the question. So like the example that I often use, because I've explained this to people before, was this image here. Let me actually, I'm going to screenshot this and bring it into the project. And we could actually, I can actually just show you the failure modes of an LLM, like just using one of the most accurate multimodal LLMs, or state of the art. So here's the image. I'm going to just put it in here. Oh, okay, there we go. So this is from the papers right here. They ask this, and this is actually a great example. So here, let me open the paper over here. They ask the LLM or the whatever setup you have. You ask it, okay, like given this image, what brand is the coffee mug, right? In ChatGPT or some other model, just looking at the entire image of pixels wouldn't really know how to answer that question. But if you see, like, this is obviously the coffee mug in question, so if we were to like take a region of interest sampling of that coffee mug, that would allow the LLM, and if we uploaded this as a separate image as context, that would allow the MLLM to reason over this second image and actually give a much, much better response. And so I can just test this like real quick right now in just like a temporary chat. Just like, let me get the image. So they actually do implement something like similar to the approach that I was going to do, where it allows the LLM to run code and iteratively segment like areas of the image to get better responses. So I'm going to tell it not to do that. So it's just going to do one pass over the image, hopefully. And hopefully it doesn't give the correct answer. But this is also why I'm implementing my second option. It is working. I don't know. I don't really know what that means. So it might be doing something fancy under the hood. But this is like kind of the motivation for my second implementation is these large pre-trained models are actually really intelligent. So it is possible that it answers this question, but I have asked the GPT the same question before and it failed. So I know it's not 100%. I really don't know what it's doing, like what this working means. It gets rid of the noise. So it doesn't get rid of the noise. It attaches that as so it's wrong. Right, the answer was Starbucks, and it just kind of said Coca-Cola probably because it's red. Yeah, So it doesn't get rid of the original image, it just uploads the second image as context, so it has additional context. It does increase like the token consumption, but you know, when you're optimizing for accuracy, it's fine. But you still upload the original image, so there is that noise there still, but you have the additional context that helps the LLM reason a little bit more. And that was like one of the biggest findings of this paper, that approach actually does in fact work. I haven't read I actually haven't read the results really, so I think it should. I think they proved that it works though. So I'm just gonna throw this screenshot in there. Okay, so I do need to implement this. I don't really know what I'm gonna do. So I do know the underlying model that I'm gonna use. Just Qwen 2.5 VLM. Okay, so we gotta figure out what size model we wanna use. I mean 7 billion I'll be able to run comfortably. I actually haven't checked my, dang dude, this is still running. So I have my own like personal AI server, and this is actually probably gonna leak my IP address, but I think it's fine. Okay, let me do this over here. I mean, it really is fine that it leaks my IP address because it's not that big of a deal. Okay, well it doesn't leak my IP address actually, but here we go. So I have a 4090 and a 5090. The only issue is that I currently am running some of ArGUS infrastructure on my server, so I do have some usage. Yeah, so about 4 gigabytes is used on my 5090. So I think I'll just work within my 4090 then. Only. Why is a 4090 so hot? I don't know, it's right here so I can like feel it. It's not that hot, but I mean 41 degrees is well within operating temperature, so it's fine. So I have about like 24 gigabytes. The problem with this like dual 50 series and 40 series setup is that I don't have like NVLink or anything, so multi-GPU usage is going to be pretty hard, and so I probably won't be doing any multi-usage or multi-GPU like inference or training or anything. So I'll probably just run off the 4090. So I'm imagining, I mean, what do we have, 24 gigabytes? So I mean, I could run a quantized 32 billion. What were the options? Yeah, I could run 32 quantized, or I could run 7B. I think 7B is a little bit more comfortable. I could run the 32 on my 5090 pretty comfortably, but again, I don't have my whole 5090. I could also move what I am currently running to my 4090 and then use my 5090. But I think I'll just start out with the 7B just in the beginning. So it should tell me how to load this model, right? Yeah. So let's just copy this. So I'll just use my 4090 in this like setup real quick. So I need another terminal window. Okay, I need transformers and whatever this is. I'm not familiar with this package. Okay. Oh, I guess I should be working just completely on my... Oh yeah, wait, this is actually... Oh yeah, wait, I'm actually an idiot. I'm downloading all this stuff onto my Mac, which is of no use to anybody, because I'm going to be training on my server. I can just copy it over. Oh wait, this is actually stupid. I'm kind of an idiot. Okay. Yeah, I guess I should copy it over. Okay, let me just see. Okay, let me just make a directory. Okay, and then I have this command that allows me to copy stuff over. Documents / code / research. What was this? That's what I called it. Okay. Why'd I name them different things? Okay, I'm gonna have to cancel this command. Yeah, it's gonna take a while actually because of this. Let me just remove this. It's gonna take a while. Okay, there we go. Now it's super fast. All right, so I'm gonna SSH in, and that will definitely leak my IP address. So let's not do that. But it's fine. I mean, I have tail scaled, so I do have a couple like security measures. Yeah, whatever. Okay. So here we go. Now we're actually on the server. So anything we do here is fun. This is all stupid. Let me just copy this. This shouldn't be done on my Mac. There's no point. Okay, I'm connecting all these terminals to my server. And then we're just going to reinstall. Let me get all of these. Okay, what was it? HF download. Okay. Good that that's downloading. Okay, now we're actually on a computer that can actually run these models. So let's activate. Can I not activate Python interpreter? Yeah, I can. So none of them are here, or the one I want. Okay, here it is. Good. Okay. There we go. So back where we were. I need the processor. And then now we'll define some sort of function. What do we name it? I'm just gonna name it ARGUS. It's not really ARGUS, but it's fun. Yeah, and let's do image path, and let's do question. And these are gonna be, that's a string. So let's say we're gonna have the image equals image.open image, and that means I'm gonna need pillow. Dude, this tab is actually really nice. So I'm just gonna write like some pseudocode. So like our step 1 is going to be well, I guess we could just use the same model, right? Qwen does output bounding boxes, if I'm not mistaken. Yeah. Oh, it's the same window I was just in. Yeah. So it can generate bounding boxes. So I could actually just reuse the same VLM. This isn't gonna be much easier than I thought, actually. And let me actually just run this little script that they give us, because it will force the oh look, they give you these commands. I guess I ran it myself, but we can run these ones too. Dang, this is gonna take forever. Okay, but I want to run this script just so that it downloads the pre-trained model. And I can just like I can continue writing this pseudocode while it's downloading. This command's gonna take a minute, bro. Is he lagging or am I tripping? I don't know. Am I lagging? Let me pull up the stream. My Wi-Fi seems pretty good. I actually didn't think about that. The Wi-Fi at my house is not as good as the Wi-Fi at my apartment. Or at my parents' house, I should say. I do have an Ethernet cable, but it's plugged into my server, obviously. It's better now? Okay. That's good. In simple words, can you explain what you're doing? I guess I should have recorded. I can actually record. In simple words, so what I'm doing is, and I kind of explained this at the beginning, but I'll just go over it again while this is installing. I don't know why this command is taking so long. So if you take an image, and I actually just did this, if you take an image like this and upload it to ChatGPT, and I say, what brand is this coffee mug right here? And I mean, some humans might even struggle with this, but I would say Starbucks, because I can obviously see that it's Starbucks, and I know what Starbucks cups looks like. And so does a VLM. A VLM knows what a Starbucks cup looks like, except when given just this entire image as context along with the query, it doesn't know what pixels to attend to more. So without getting into, you said actually in the simplest words as possible. I was about to explain how the attention mechanism works, but regardless, VLMs and LLMs and transformers as a whole have this thing called attention, where they look at tokens, and that's all that this will be represented by, this image, like tokens in some sort of embedding space. And they put attention to them, and based off of their attention, that will impact how much influence they have on the probability distribution of the next prediction or the next token, right? So a VLM would take in an image and a query, attend to whatever regions of this image it decides, and then gives it an output with those like influencing its next token prediction, right? So in this image, you'd probably have some attention or higher levels of attention over towards this area of the image, but it doesn't actually get to zoom in and look at that area of the image like you do with your eyes. Your eyes, like, you focus. Like if someone says, what brand is the coffee mug? I'm not gonna even look over here. Like, this is included in context. My brain can see this, like this fan, but I'm not focusing on this fan, I'm focusing on the cup. And so what I'm trying to do is allow the VLM to actually focus on the region of interest that will help it answer the question. So for an image like this, and we can look at the ARGUS paper, they literally did this exact image. Instead of just passing, like naively, what you would do is you just pass this entire image in the query to a VLM and get your output. But what they propose is sending this entire image alongside a region of interest sampling, which is just like a segmentation of the image of the area that you think will lead to the correct answer, and passing that as context alongside the original image, and that they prove gives better results. And it's actually like kind of counterintuitive, because you'd think that the LLMs or the multimodal LLMs underlying, and I use multimodal LLM and VLM interchangeably, the attention mechanism would kind of make this not necessary, but as we saw with ChatGPT, it did not give a correct prediction, so of course the attention mechanism is not strong enough to make this like irrelevant, to make region of interest sampling irrelevant. Okay, I don't understand why this is taking so long. All I'm trying to do is install transformers. Both of these, I'm just waiting for both of these to finish. Okay, well, I guess we can do this first. So the first step is obviously to get your region of interest, right? So we'll have to get some bounding boxes, and as I just read, Qwen can natively output the bounding boxes. And so we're just gonna leverage that. I'm not actually gonna type up the code. So let's get our region of interest sampling, I guess. And this we're just gonna ask the VLM to locate regions of interest, relevant regions, using bounding boxes. Bounding box annotation's fun. So this is just going to be a normal message, and this is actually going to be so much easier than I thought, because I'm not doing the full re-implementation. Wait, hold on, let me see this. Message, image equals this. Text equals processors.apply chat template. Okay, I think I can just copy this pretty much. And we're going to tab all that over, and we're going to rename this to ground message. Alright, I'll actually be pretty, I'll be verbose. And image is going to be image, and question is not going to be question. Question is going to be, oh, and we might need an F string. Can I do that within a thing? Yeah, I guess I can. I'm going to collapse a lot of this because it's hard to read it like this. I don't like this. My goal is to do this in as little lines of code as possible. So we have the role, user content, content type, image. Add a space here, add a space here. And what is this final comma for? It's not needed, right? Let's add some spaces. And this comma is also not needed. Yeah, I don't know why it does all these trailing commas. Okay, so tab is telling me what I should do. And let's just tell it the bounding box of relevant image regions in this image of the relevant regions of this image. And I'm just going to say with respect to this question. And tab should do that for me. Good. Okay, perfect. Okay, so I guess I can, let me just do 2 rows. Wait, why are there so many things? Oh, I see. It's fine. Just leave it. Who cares? I'm trying to make the code like look as good as possible, but who really cares? Okay, so then we run inference and parse the output for the box, for the bounding box coordinates. It's fine. And so then we go into step 2. So obviously it's not the same thing. So step 2 is going to be let me see. Where's the methods? Implementation details. Yeah, I see that they're normalized from 0 to 1. I don't know if that'll be necessary. That's going to be an implementation thing. We'll see. We'll see if that's necessary. Okay, so step 2 is going to be let's crop the region of interest, and I can just put a dictionary up here. Region of interest, VLM, vision language model, MLLM, multimodal large language model. Dude, this thing's pretty good. Tab is pretty good. ARGUS. ARGUS is a framework for visual question answering. That's funny. What are other acronyms I'm using? I guess we'll just, there's one more chain of thought. And this is going to be lowercase t. Chain of thought. Okay. So crop the region of interest and add, I'll just say with padding. So another issue with region of interest is that it can be too constraining, and it diminishes the helpfulness. I mean, this initial box would still be helpful, but expanding the region of interest and adding padding, I guess they proved that it increased performance. I mean, I can test it myself, but you could only imagine that expanding, and I'm not going to do, they did like a more complicated expansion, but I'm just going to add pixels in every direction. Just a square padding. And I'll do that later. Step 3, that's like not even, Wait, this is actually... This might be too naive. Like, I'm not even doing anything. This is gonna be like 10 lines, 15 lines of code. I need this to take a longer amount of time. Bro, I'm gonna be done with this in like 10 minutes if this is what I really am doing. Like they re-implemented the whole underlying model essentially. Okay, let me do this initial implementation, then we can dive deeper if needed. But this is just 3 steps. Like this will be re-engage the VLM, send both the cropped region of interest and the original I can do it like this. The cropped plus original, cropped region of interest and the question back to the MLLM. And it's not it's just a VLM. Bro, this is literally gonna be 10 lines of code, like legitimately. Okay, cropped, and I said I would be like verbose in my well, actually first I'm gonna need the width and the height. Yes, good. Crop equals okay, just leave this as that. Okay, how do I get bounding boxes from this thing? You on spring break? Yeah, I am. What's up, Brain? Share the link to this paper? Okay. Yeah, I should probably put it in the description, actually. Otherwise, I'm gonna get in trouble. How do I do that? How do I change the description? I don't know how to change the description, actually. Okay, here we go. Alright, I added it to the description. Chat miss? What are you saying? What does chat miss mean? Okay, so this is still running. That's like completely unbelievable. And I think this is done. Okay, so we have our data set. see. A lot of things are happening at once. Okay, there we go. Do you know how to use the IDE Z? You got 35 people watching you. How you feel? I'm very nervous. Okay, so I gotta figure out how to run inference to get bounding boxes. Oh yeah, that's exactly what I did. Max size equals 1280. Wait, am I gonna have to benchmark this? Just realized I might have to. That's gonna be annoying. Oh, look at this. Or you can send the... Why did we resize? What is this? Okay, I imagine it's not going to be too difficult. I'm not gonna look at these until I actually run into the problems myself. Do we think the pip command is done? Finally. I think I have to do this. Yeah, nice. Okay, now we can just run this script really quickly. And this will load the VLM for me. Let me get torch for stable Linux pip Python CUDA what? I think I have CUDA 13. Yeah, CUDA 13. Cannot import module. Are this object's requirements defined correctly? You tell me, bro. Literally copy and pasted this code from Hugging Face. What is it saying on what line? line 1. Oh, that's great. I actually don't know what's going on here. Maybe I'm supposed to know, but the big dog can tell me. Conda run. Yeah, sure. Wait, why is PyTorch 12.8? What is he trying to do? Reinstall? I want to use... How are you doing? I'm doing well. What's good, Harsh? But your PyTorch 12.8 was installed. Dude, I literally installed CUDA. Okay, let me do this. So force the reinstall. This actually takes a long time because CUDA is like pretty large. I think it's like 3 gigabytes or something. But my computer is pretty fast. Should be fun. Okay, there we go. There we go. Okay, so it's gonna load the model, and while that's loading, let's continue. So let's come back to my script. So we're gonna define like a bunch of helper functions actually, instead of trying to do it all in one function. So we're gonna do generate and just pass for now. And we're gonna do parse bounding box and crop region of interest. And that actually might be it. That might be all we need. So generate is just going to be this normal thing. Oh wow, look at this. Text equals apply chat template. That actually looks right. So obviously none of this needs to be tabbed over. And then let's define some like max tokens. It's gonna be an int, but we're not typing anyways right now, so. And we'll say max new tokens. It's actually better. So apply chat template, tokenize false, add generation prompt, true. Okay, image input, video input is going to be nothing. Process vision info, messages, input equals processor. This actually like all looks great, let's do 2 CUDA. And this is going to be, we need torch. Torch.no gradient. That actually should be fun. Max new token, deal with max new token, that's fine. And we're just gonna return processor. I think it's dot decode. Batch decode. Shut up. I don't know what the difference between decode and batch decode is, but we're going to say the IDs. Oh no, generated IDs. Okay, fine. We can do it like that. I don't know what any of this is, just ignore this. This is going to be generated 0. And then second dimension is going to be the length. Inputs. That should work. Okay, that should be good. And we're gonna skip the text. Clean up tokenization space. I don't even know what that does, but they had it in their example, and we'll strip it. Okay. Okay, so the only problem here is that but this should run, so it should be fun. We'll get runtime errors if it doesn't work, so cross that bridge when we get there. So we want the parse bounding boxes. We're going to take in some text and some width and some height. And wait, did we have an example of the bounding boxes actually? Let me see, wait, hold on. Image path, prompt, formatted prompt, output, okay. It really, all you have to do is ask it. Why'd they do it like that? Can we trust this Medium article? What do we think? Yo, what do we think? Stream lagging? Bro, is the stream actually lagging? It's not lagging for me. I have it playing. Maybe the video is. I'm not watching it. I'm just listening. Ollie Guliev says no, it's not. I trust Ollie Guliev. Yo, Ollie, wasn't that crazy that guy found you on his Instagram Reels? Wasn't that insane? Okay, so I'm basically just gonna copy this guy's thing. So I have it in. Oh yeah, I think this is right. Yeah, I think I should accept this tab. But he is right. I do need to import JSON, and let's separate these imports. We're gonna need JSON, and we're gonna need re. Okay, I'm literally just gonna copy like pretty much exactly what this guy has. So text equals text dot replace. So it's gonna output a code block of JSON, and this actually. This tab looks right actually. Dot replace the output, yeah. And then we're gonna strip that. So we're gonna try to load the text, and if is instant data, if data is a dictionary, not a list. And I don't care about its length. If data is a dictionary, then the data equals, list of the data. Okay, and then we're gonna return the data. Except just do nothing. Just throw an error. Throw some sort of error. Can we, oh no, raise value error. Okay, good. And then by default, we're gonna return none. This should work. It would be nice to have a fallback here. It would be nice to have fallback. Is it listening to me? Wait, is it actually listening to me? Oh, return none is never gonna get hit. Yeah. So we don't need it. Okay. And then we don't need to crop the region of interest. What we need to do is normalize the bounding box. And we're just going to take in the image because we don't need width and height. We get that from the image and the bounding box. I'm being really verbose with my variable names, but it's fun. So we were going to convert Doesn't matter. You can read the code. You don't need that thing. So the width and the height is going to be the image size. So processed image equals processor, not of the image, of the image. Yeah, that looks right. Okay, and so okay, we're just gonna copy this. Okay, he does it much more simply, so we're gonna have the H patches and the width patches. And this is gonna equal the processed image grid. This first index. Oh, sorry. Sorry, Python, my fault. And the input height, input width equals, these need to be integers. And I believe they need to be multiplied by 14. And so this will give us our coordinates, like it says. It said it here. It's like x1, y1, whatever. Where was it? x1, y1, x2, y2. So we have x1, y1, x2, y2 equals bounding box. Okay, so we gotta normalize all of these. We do x1 divided by input width times the width, and just keep doing that for all of them. Input width, input height. Yeah. And then we just return them. Okay. Great. Done with that. Oh, did I get rid of crop region of interest? We still need that. Image, bounding box, and let's expand it by 0.2. So we're going to get the width and the height of the image. Again, this actually looks mostly correct. Actual one, bounding box, it's fine. Okay, I'm gonna just do this. Bounding box width and bounding height equals x2 minus x1. Yeah. So that's the width and the height, and we're gonna say x1 and y1 equal the max of 0. Oh, look, this might be correct. 0. Yeah, okay, the only problem is this needs to be an integer. There. Okay. And we're basically going to have the same thing for the x2, y2. Let's ignore the tab for now, because I don't know what it's going to do. This is going to be the minimum is the width. The minimum is the height. And this is not going to be this. This is going to be x2 plus. This is going to be y2 plus. Yeah, it should be right. Okay, moving on. So we're going to add just a square padding, like I said. It's really naive. What they do is they do like, I don't even know what they do actually, I don't remember. But they do something different. It's much more complicated what they do. But they weren't doing it in an hour, which is how long this is going to take. That looks right. And then I don't really care about this stuff. I mean, this is wrong, but that's right. And that should be right. Okay, image.crop of this. Okay, now on to the real part. So we're going to take in some image path and some question, open the image, send the grounding message, which is going to be roll. Okay, we can add the system prompt. Dude, this tab like actually knows what I want. You are a helpful assistant that can output the bounding box coordinates of the relevant regions of the image. That's couldn't have said it better myself. Role user content type image. Image is image. Okay, I'll do this. Fine. Let's tab this over. Wait, what did it just do? Let's tab this over. Do this. Apparently there's an error. Yeah, wait, why would I do that? Just do this. Okay. So image is image, image, text. I'll put the bounding box of the single most relevant region. I'm just gonna do one, and this could, I mean, you could benchmark this, how many regions of interest you should use, but I'm just gonna do one region of interest. Okay, and I'm gonna say report the bounding box coordinates in JSON. I believe that's all I have to do. Okay, now run inference. The raw output, raw response is going to equal generate grounding message. Max tokens is default value, it's fine. And we're going to print the raw response. Let's bounding box. Oh wow, yeah, that's right. Raw response. We don't need to put that because yeah, we don't need it with the 9. Okay. So this will parse the JSON output that the VLM gives us and get the bounding boxes. And so now we're not going to do a fallback if there's no bounding boxes. If not, bounding box, then yeah, raise a value error. Just simply for now, we're not going to do any fallbacks yet. Okay, so we're going to use the first most relevant bounding box because, I mean, it could output more than one just if it's not listening to me. So we're going to do the raw box is just going to equal bounding box JSON. It's going to be the first instance, and they're called bounding box 2D. Okay, and so the label is going to equal the bounding box JSON label. This has to be a .get. And also could be empty or something. Okay. Now the actual bounding box is going to equal the normalize bounding box image and the raw bounding box, and we're going to print that. Sure. And the label, fine. Okay, step 2. Crop the region of interest. That actually looks correct. Wait, hold on. There's a cropped region of interest with the image and the real bounding box. And I guess we can print that. No, there's no reason to print that. Okay. So now it's just step 3. That's all that's all there is for step 2. Okay, now we need to pass the original image and dude, this tab is like actually good. Like this is legitimately what I want. That can reason about the image in the question. Okay. The role user content, we have the image, we have the cropped image, cropped region of interest, and we're gonna say image 1 is the full scene, image 2 is a zoomed crop of, and this is we're gonna reuse the label. Using both images, answer the following question. Okay, raw response equals generated reasoning message, print raw response. Okay, let's try it with an image. Should we just do this image? Should we just do this image? Okay, so we're gonna call image path and question. Let's do the same exact question we asked GPT. Okay. Argus image path question. Okay, this, I say there's probably like a 5% chance this code compiles. Okay, so the model loaded and it works, so let's try. No way it's working. Okay, yeah, that's what I thought. Okay, so on line 37, list has no attribute strip. It's a list? Wait, can I just do normal decode? Okay, there. Oh my gosh, wait, it worked. Yo, it worked. Oh my gosh, no. No, it worked. The coffee mug in image 2 appears to be from Starbucks, as indicated by the recognizable red and white color scheme. Yo, it worked. Bro, what is life? How did that work? Yo, Argus confirmed? Yo, it worked. No way. The funny thing is, like, I really do have no idea what even happened because I'm not saving any of the images, like the region of interest image. So I really have no idea what the region of image was, or the region of interest was. But it's working. Let's see. Okay, let me just hold on. I could be getting duped. I could be getting duped. Let's see if it works without the region of interest. At least the code compiles though. Okay, yeah, it works without the region of interest. It works without the region of interest, so this actually does not. I didn't prove anything. I didn't prove anything at all. Okay, I mean, ideally what I would do is evaluate on this data set. But before that, I do want to save the image. And they did this in this Medium article. Where'd the Medium article go? Okay. So he did. You just have to put the plot image with bounding boxes. Let me just copy this entire code. Where's my thing? Okay, plot image with boxes. What are the parameters? I need these two. And MLLM. Perfect. Wait, what are the parameters did we say? The processor, the image, and the bounding boxes. Okay. So we'll do it. Wait. Wait, I'm actually just gonna hold on. Let me just steal this. Delete this file. Oh yeah, I do have to do that. Or actually save it to, we should save it to a file. And we have to move this down below. Okay, I'm gonna ask it. Wait. Okay. Wait, does red and white indicate that it's Starbucks? Well, I mean, it is Starbucks. Like, that is what it is. Like, that is the correct answer. So, I don't know how GPT didn't get it, but this, like, tiny little VLM got it 0 shot. Dude, what is it thinking about? I'm asking it to just do some matplotlib stuff. Can it hurry up? Also, no, I don't need the also. Enriched response. Baseline. So no cropped region of interest, only one image. Okay. So this is gonna say, dude, can this thing hurry up? Like, I put the AI on this because I thought it was something really trivial that takes like 5 seconds. Fixing what? Get padded region of interest box. Thought I already did that. Dude, what is it doing? Bro, can we actually be so serious? Why is it doing this? Okay, yeah, I can do whatever it wants with this function, but I don't understand why it had to change my stuff. Wait, can we talk about how this is the exact same thing? Bro, is this being serious? Wait, hold on. Why did it do this? I'm just not gonna do that. If it wanted an extra function, like it can just have it. Okay, fine. But just don't ruin my code. Do this. Okay. Now it should work. Wait, where is it gonna save it? Oh, I'm gonna have an error. Isn't crop region of interest still a function? Wait, where'd that go? Wait, why is this gone? Put this back. Okay, I really don't know where this is gonna save, but bro, okay, well it works with both. Yeah. So the region of interest looks good. That's correct. The problem is, and we can just keep all of this. The problem is that how is this model better than GPT, bro? GPT didn't get this 0 shot. Oh, this should say baseline. What if there are more than one cup? Well, I haven't done that yet. I mean, you could allow it to create a list of regions of interest, but I'm just using one region of interest for now. I do want to look at this data set though. It should just be like one region of interest on all of them. Okay, do we want to evaluate? So I imagine we'll have to we can just get the mean squared error on bounding box difference, and then maybe do like cosine similarity to get, because the only problem with like the strings is the strings will not be the exact same, obviously. Dude, I'm really upset that the baseline is working, bro. I was expecting the baseline to not work, and then the reasoning would be like so much better and work. Hold on. Does the baseline work every single time? Like, if it does, then yeah, Starbucks. Bro, gosh darn it. We can actually copy like all of this out of here. I'm just gonna test the baseline like 5 times. Yeah, it's Starbucks every time. Alright, the baseline works. Like, that's annoying. Where does Qwen get off making a stronger 7 billion parameter VLM than GPT is? But like, GPT got it wrong, but the VLM got it right. 7 billion parameters, by the way. It kind of outputs the same exact text every time. Oh no, merchandise. Okay, let's do a harder image. I'm trying to think. I don't really have any images, but we can just use one from this data set. Can I just open like the images? I don't think so. Okay, we're gonna have to actually evaluate it. So let me just write this evaluation function. This is gonna be a little bit harder though, because I actually have to do some math. Shouldn't be that bad though. Visual chain of thought. And this is gonna take in data set path. It's gonna be this one. Nah, we're within the ARGUS folder already, so. And then we'll just do some sort of count. How many there are. file's huge. Why is it so large? Why is this image so large? It's undoable. Okay. So dataset path R as F should be fun. We don't need to say read. Data JSON.load F. Okay, correct. Argus. Correct baseline. And like a total. Common OAIL facts. Ayo. Okay, that actually is like right, except we're gonna call them samples, and it's in the world. So conversations. Okay, bro. Okay, this is turn 0, where the human asks the question. So we're going to say the question equals replace image \n nothing. And we're going to split it. So please. And then now we want 0, 1, 2, 3. So from GPT, so this is the ground truth. It's going to be 3. It's going to be the value, and we're going to strip it, and we're going to lowercase it. Yeah, I mean, string comparison is not going to work, bro. This is going to be 0. And so then we'll try to open the image. If it doesn't work, then we're going to throw an exception. So just say file not found error. No, don't continue. Yeah, sure, whatever. Yeah, don't continue. Argus answer is going to equal Argus image path question, and we're going to strip it and we're going to lowercase it. Base message is going to equal something along the lines of this. We won't have a system prompt. So it's going to have the user, and the content going to be the image, and the text is just going to be the question. What is this error? Wait, what is this? This is not closed, is it not? I think I have an extra. Yeah, there we go. Okay. So the base answer is generate base message dot strip dot lower. Nice. Okay, and then this is just like not gonna work. Okay, but it's fine. So answer is okay equals ground truth in Argus answer, or Argus, no, or Argus answer in ground truth, and baseline okay equals ground truth and base answer, or base answer and ground truth, correct Argus plus equals answer okay, correct baseline okay, total plus 1, print correct fine. Let's print the total. Okay. Okay. So first thing we need to do is cd into visual. We're gonna make dir this, and we're gonna for f in the tar split slash images star, we're gonna unzip and this is gonna be the path, and we'll be done. I really don't know what I'm doing here, so I'm just trying to unzip these, bro. Is this the setup in your 4th house? How were you able to screenshot on PC and drag it to your iPad? That was just Mac. Mac, you can do that on Mac for some reason. Sick, right? That's running in the background. Pipe together into a single tar extraction. What is it doing? Wait, what is it doing? I didn't even look at the command that it ran. Is this it? Ryan Reynolds? Wait, what is this exactly? This is a very large data set. Wait, why would I do this? There's a lot of stuff going on in the background. My Concha. It's something you can do on Macs, bro. It's native. I didn't do anything. All the Mac just does it itself. Oh, am I in the directory? It can figure it out. Yeah, there we go. Let's let it think now, because this is actually changing thinking. Yeah, whatever, bro. Let's go to Opus. All right, let me see. It didn't even read whatever was before the question mark. Oh. So you literally just screenshot and drag it to the iPad screen? Yeah, bro. It's like exactly what I did. Okay, just let this do whatever it wants. On Mac, like, you can copy and paste. Yeah, you can copy and paste, but you can literally drag it over. Like, I can literally drag it like it's just another screen. Like, I just move my mouse towards my iPad and it just does everything else. Okay, what is it saying? The issues are... No, it's so stupid. It didn't read. Argus returned none. What? Argus does not return none. I just did it. Is it saying if Argus returns none? Which it can. Oh wait, it doesn't return anything. Wait, how is this working? Okay, whatever. It doesn't matter. I remember now. I see. Yeah, Argus doesn't have to return anything. I knew that. Image path format, the dataset has entries like this, and also your code does sample. Wait, chain of thought is empty, dummy. Oh, it's here. 12. Yeah, chain of thought is empty because it went here. It's my grandma. The mouse of the iPad thing is extremely annoying. Yeah, it can be sometimes. Okay, bounding box, format, mismatch, whatever, conversation parsing, uses key value, but the use blah, blah, blah. Wait, how? I was trying to make a new line. Whatever, he'll figure it out. Okay, can it do any of the things that it's been saying? Okay. Yo, I'm probably the best prompter in human history. But the reason I don't really care is because this is like such a trivial task. All it's doing is figuring out the directories of all these things, making sure they align with this JSON that I'm parsing, and making sure my code will run. So trivial. I already did all the work. It's only 250 lines of code. Like, that's pretty small. I told it to do too much. Like, let's get on with this already. Is this how you're supposed to do AI research? Do AI research. Do not mess up. Make sure it is publishable. Make it sound like human. No mistakes. Make it sound like human, no mistakes. Okay, wait, let me see what it's doing. It's typing all my code and it's fine. Doesn't like my formatting. Alright, that's fine. It's removing my comments. Dude, why do we allow these LLMs to do anything? Okay, good. Okay, this is actually a really good change. It added a line and removed a line. That's good. Okay, I'm glad. Yeah, no, this is actually good that I'm using the AI, because if I had the space on, or the empty line on 169 instead of 168, we'd have a lot of problems. This does look right though. I actually did have a problem, and I guess there's a typo. answer, enrich response, return answer. Or it completely remove my baseline. Okay, it's fine. Sure, I don't like how it removed my comment. And it corrected my typo. Like, what if I wanted that typo? And then also this minus plus one line is actually making me mad. But whatever. Okay, let me get my comment back. Cause how dare it? How dare it touch my code and touch my comments? All right, what is it doing? Pi right? Do you want to proceed? Yes. Yes, install it. Oops, I just interrupted it. My bad. My bad. Continue. Dear ChatGPT, please make me the most cracked project that will get me into OpenAI, Anthropic, Google, Jane Street, and Hudson River trading. $4 million rows affected. Oh, that's good. Yeah, I imagine this whole function was bad, so just whatever. Do whatever you want. It's typing my code. It's correcting my mistakes. And it's skipping image not found. Okay, done. Image path remapped, graceful skip, save annotated equals false by default. No plot overhead during eval. Yeah, we don't want to plot it actually. That's a good idea. Okay, def main. Main is just going to run evaluate. Chain of thought. So, should I just run this? What GPU is this even running on? I guess I never even checked because it's so small. It can run on either. Is it running on both, really? Okay, let's let it just run for a couple seconds and I'm just gonna look. Okay, that's good enough. Apparently it's running on both GPUs. That's really strange behavior. Okay, raw response. Okay. Normalized bounding was whatever. Enrich response, whatever. Can you tell me about the hairstyles of the individuals in this image? Okay. They have shaggy hair. Argus false, base false. The individual. What image is this? Can we do image path? Okay, run this again for 3 seconds. I just want to see what images. What images this is using. And obviously like my evaluation conditions are not good. Like doing a match on a string match is obviously not going to work, so. Okay, let's open this. Can you tell me about the hairstyle? The individual on the left has short hair. It's not even really right. Okay, you know what I'm gonna do? Yeah, okay. Q. Wait, what are all the things? We have the Argus base GT. Q Argus base GT. Okay. All right, and I'm gonna use an embedding model because what's like the state-of-the-art embedding model right now? I could even use the VLM. Just use its embedding space, but that's lame. Sentence transformers. Sort most downloads. 2025, it's fun, who cares? This is an example sentence. Each sentence is converted. Embeddings, embedding. Nice. This will work, and we need to go back over here. Okay, from sentence transformers, let's install that. No sentences. Embedding model. And let's take this. Okay, so we gotta wait for Claude Code to finish what he was doing. Read this. Yes, do it. Embed image. Def, and I guess we could do compare answers. Answer 1, answer 2. Embedding 1. Embeddings 2. Embedding model dot encode answer 1. And oh wow, look at this. That's cosine similarity. Is the dot product. Wait, hold on. The cosine equals. It's like some dot product divided by the normalization. By this size. Yeah, that should be right. Okay, and this will give me something, let's do 0.7. So this will give me a Boolean. Okay, so 0.7 is fine. So what is Claude Code doing? He's still not done? Okay, also use my let's do 0.5 because I imagine they'll actually have some different. No, 0.7 is fine. Yeah, whatever. What made you decide to study physics in university? It's what I decided when I was a senior in high school. So that's what made me do it. Dude, Claude Code is doing my AI research. Is this tough? Search pattern, compare answers. Bro, what is it doing? Can it not see my code? Found 27 lines. Plus compare answers. Nice. Okay, let's see what it's doing. Annotated save path. Sure, whatever you want. Huh. Maybe something was happening. Okay, let's see. Evaluate again. Output directory, evaluation results. Ground truth. Yeah, you don't have to lower it anymore, but it's fine. Annotated. Argus answer. Base answer. Answer okay. Baseline okay. Okay. Yes. Wait, and lastly, I want to also include the non-Argus answer. So just the raw VLM, no region of interest. Just the original image and query. Okay, this is the most important part, is comparing it against the original. Oh, it's already there. It sends just the image with the enter with no region of interest crop, and it's already saved in the JSON and checked. Oh, nice. Kind of forgot about that. Oh yeah, yeah. Okay. So let's continue by running this again. Wait, is it gonna save it? Status unexpected. Can be ignored when loading from different tasks. What is this? BERT model load report. Embedding position ID status unexpected. What does that even mean? Okay, whatever. I think it should be fun. I really don't know what that means, but... Okay, yeah, it's printing all this stuff. Who cares? Eval results. Results.json. They're both false. Argus correct, baseline correct. Why are they both false? All right, instead of returning true or false, plus equals answer. Okay. Wait, what is this? Plus equals. Yeah, we can do that. That should work, actually. Greater than equals would be just so useless here because it should be a float, so it's almost impossible for them to be equal, but I guess we can do whatever, I don't care. Okay, now this shouldn't error. Let's delete these again. Why is it still saying true? Wait, why is it still saying true? This should be a float. Oh, bool. Yeah. No, stop that. Retry, buddy. Wait, is this gonna... Okay, good. Oh, it gave me an error. Okay, good. Object of type float32 is not JSON serializable. Why not? Wait, why is this not JSON serializable? I guess JSON can't use floats, so just do it as a string. Do it as a string. Did it as a string 0.4, 0.5, 0.4, 0.5, 0.7 is green, is blue. Wait, it's green? Image 2. I would say it's blue, bro. Why is the baseline, why is the answer green? The ground truth is green. This is blue, bro. Yo, who made this data set, like, actually? Bro, it's not even performing that much better than the baseline. Number 17. Apart from the window, is there another object? Single most relevant region. I guess the window frame, maybe? Which one is this? Number 17. He's using the ladder. These, wait, hold on. These are not the best images to be using. Dude, how many times did it call that same image? Yeah, these images aren't that good. Like, the usefulness of chain of thought is for like harder to see things. Like a huge, like I think of a huge image, coding it in light mode. I sent a chat earlier. Anyway, have you tried learning about microcontrollers? Oh yeah, a little bit actually. I've learned about microcontrollers actually. I have a ton of microcontrollers at my house. Yeah, I have like 5 Arduinos. I have 2 Raspberry Pis. I have a Jetson Nano is not really a microcontroller, but you can like kind of make it be like one. And then I have like actual real microcontrollers from my ECE labs. Here's this has some microcontrollers in it. This big box. I have this big box. This has tons of Arduinos in it. Has like 3 Arduinos in it. Oh, it's an NFC reader. Whatever. Yeah, so I've experimented with microcontrollers before, but that was all freshman year, back when I thought I was interested in ECE. Okay, so what did I want to do? I wanted to find the single best image to test this setup. So let me see, like, they use some of these images. No, that would get 0-shotted. Yeah, see, like an image that just has a bunch of stuff in it. Find me an image that has a bunch of stuff in it. Bro, I am a very optimal AI researcher. Oh, where's Waldo? What a perfect example. Well, not really though. 'Cause how is it even gonna get a good region of interest? This would work if I allowed it to do more than one region of interest. Copy image. Wait, can I just paste it? Does that work? Yes, it does. Okay. So, all right, let me do that. Wait, is this done? Yeah, it is. Oh, look, ARGUS performed better. Whatever, who cares? This is 10:02. All right, so I'm gonna do this image. I'm gonna test this image. Okay. Yeah. There we go. Image path question. We don't need this one. So this should, bro, why do I keep typo? A equals ARGUS, B equals baseline. Okay, image.png. All right, let's see what our question should be. Our question should be on the patio, or on the patio. Yeah, that's what I'll say. On the patio. What color are the majority of people on the patio wearing? Don't save. Let's do this as the question. This should work just out of the box. What do these even return? Return, generate, whatever. Okay. Just print ARGUS baseline. Bro, okay, it actually works. Let's go, bro. This is way better. Bro, I just created my own benchmark that's way better than the benchmark from this benchmarking consortium. Bro, okay, this actually proves that it works. Look, the majority of people on the patio in image 1 appear to be wearing black. Right? That is correct. The majority of people on the patio are wearing black. 1, 2, 3, 4, 5. 5 people. The baseline says on the sidewalk. I don't even know what they're talking about on the sidewalk. It's difficult to determine a specific color that is worn by the majority without a more detailed analysis or color frequency count. Dude, I'm him. I just proved that it works. I think this would hold up, right? Just one single evaluation. Just one single test. One single test, bro. Why do you need more than one test, bro? As long as the test proves that what you set out to do happened, then there's no need to retest. Nah, should I create my own data set? I guess I should. I'm gonna create my own benchmark. Benchmark.json. Okay, let's open this up. Wait, how do we do this again? Oh wait, no, that's not how you write JSON. This is how you write JSON. So we're gonna have this. And this. Okay, this is valid JSON. All right, so we're gonna have image. We're gonna have image path. Images. Image.json. Benchmark. No, image.png. Wait, images. Let's just name them 1. 1.png. Images. /images. Oh wait, but now I'm gonna have a problem with the paths. We'll figure it out when we get there. Question. Oh, look at that. It brought over my question. Oh, but we're gonna have to say the ground truth is just gonna be me. Are wearing black. Period. Okay, that's all we need, right? Question, image, ground truth. Nice. Let's continue with more images. I don't know how these images with different dimensions are gonna work. Like at all. Name this to be 2.png. Okay, can we split view this? We're making our own benchmark. Image path, that's correct. What instrument? No, wait, hold on, let me see. What? Oh no, I can't do color again. Well, actually, color is probably the easiest thing to do because okay, I'll do what animal is on the roof. That's it. That's my own. That's the whole question. A cat is on the roof. Yo, wait. Why does Tab actually know the answer? What city is this? Oh yeah, let me do that. Let me do that question. Bro, how did Cursor know the answer? I'm just gonna do like 4 images or something. It's just a little tiny data set. Okay, let me see a question I can ask here. Is that a merry-go-round? I can't really tell. Okay, you know, this question is actually hard. I don't even think the region of interest is gonna get this one. How many kids are hanging on the monkey bars? There are 2 kids. I'm just gonna do this for the cosine similarity should pick it up anyways, but there are 2 kids hanging on the monkey bars. I don't know what that is. Well, okay, where is it getting these images from? Like, let's just get more of these. Busy pictures for ESL. I don't know what ESL is. English as a second language? Alright, we get it, bro. How do I copy the image? I don't want to sign in. Whatever. I can't sign in, it won't let me. Hello? Dude, I just want to copy the image. Like, how hard is this? Okay, why can't I log in? Oh, look, I have an account. Hold on. Okay, it's fine. All right, so this image, we're gonna say, no, that question's too easy. For these, I can't think of any questions. Yo, this picture's low-key pretty explicit. I have to do a question where the region of interest can be easily found, but within the region of interest, there's like a harder question to answer. If that makes sense. Just because I don't have multiple, I don't allow it to make multiple regions of interest. Should I ask it what time is on the clock? There's no way. I low-key don't even know. Wait, what time is that? Bro, the clock has more than 12 hands, doesn't it? 1, 2, 3, 4, 5, 6. Oh no, it doesn't. Okay. So it's like 10, 11. It's like 10, 11. Ask what time is it? Just what time is it? That's funny. Yeah, it is 12 o'clock. That is not true. I think it's like, it is roughly 10. Wait. Past 10 minutes. Is that right? I mean, this is like 10, 10, 10, 11. I'm just going to say 10, 11, 10, 12. These are all the acceptable answers. 10, 11, 10, 12, 10, 13. It's really not 10, 14 or 10, 15, so. Or how many are in the hot tub? Yeah, that's what I was thinking of doing, is how many people are in the hot tub. We can actually do it twice. Like, I can do the same picture twice. Oh, I don't have to duplicate it. I'm an idiot. How many people are in the hot tub? The problem is I don't know if the region of interest is going to be right for this one. Okay, we'll do one more image, so 5 images in total. So where'd ChatGPT get this one from? This is also Pinterest. This one looks pretty interesting. Okay. And now we'll do the last one. Image 5. Okay. Dude, I could ask so many questions about each and every one of these. There are 2 dogs. The animals on top of the pumpkins are dogs. There are 2 dogs on top of the pumpkins. Okay, I'm gonna ask another question about this image because it's a really easy question to ask, or a really easy image to ask questions about. What is on top of the motorcycle, the black motorcycle? And what color is it? There is a helmet on top of the black motorcycle. It is blue. Okay, and then we can ask one more question. Let's do one that's a little bit trickier. I want to do one like in the middle of the image. This is not a good image for another one. Let me get another one, but from a different image. Let me do a different image. There's got to be something that's like unique. Oh wow, this one's crazy. Did I not copy it? Hello? Copy image. Paste. It's not working. What the F? Maybe I have to open it in actual tab. Okay, it's not working. I have to save it. What is this, 6? It's a JPEG. Argus / benchmark. It doesn't matter, just move it there. And I can move it. Okay, this is the last one. We're gonna say wait, this image kind of sucks. And it's a puzzle. Wait, this image sucks. This image sucks. I just wasted my time. This image is terrible. These are all puzzles or something. Let's go back to this one. Maybe this one. Yeah. Let's do this image. Bro, why can't I paste these, bro? Save image as. Replace. Did not work. Delete permanently. Oh, I moved it here, that's why. Yeah. Okay. Let's see. I want to do one in the middle. The umbrella. Okay, I'm gonna say what is the lady with the umbrella selling? Hopefully there's not more than one people with umbrellas. They are selling fruit. She is selling watermelon. Let me just do, I'm just gonna do a comma separated list of like possible watermelon, banana, pineapple, apple. Just so that if it says any of those things, we get a good cosine similarity. Yeah, there's only one umbrella in the whole picture. Perfect. All right, so boom, boom, boom. All right, so now we need to evaluate mine. Evaluate against my benchmark. The benchmark path is benchmark/benchmark.json. Root image root path is /benchmark. That's correct. Eval results. That's fine. Okay. So the data loads for sample and data. No, I'm not doing this manually. I created my own benchmark. Do the same thing for it. Update my function. Use my benchmark and output the JSON, the annotated image, and add the real chain of thought region of interest sample that's sent to the VLM. Okay. Do mine? What is yours? Hugh Hefner chilling at the bottom right. Who's that? How many tomatoes dropped? Where I couldn't even answer that question. No, but the problem is that VLMs are autoregressive. So things like how many, and this isn't like it doesn't have reasoning. Like it can't output thinking tokens. So asking it to count is really not, it's not going to be representative of like anything. You know what I mean? Like it's autoregressive. It doesn't have the ability to like iteratively actually count. I mean, I could instruct it to output tokens until it reaches like a number, but it still wouldn't be that good of a, that would be a great query for a thinking model. If we were able to output thinking tokens, or if it was able to iteratively look at the image until it like finalizes some incremental answer, that could work. But with this setup, it's not optimal. But that would be a good question, actually. And when I do my other approach, that actually would be like a very optimal answer, or a very optimal question. Yeah, make the changes, bro. Do any brown people exist? Yeah, the reason of interest would be the entire image. That really helps me. I think a normal, the shark swimming, I was actually thinking of doing that. Wait, can I actually read the code that I did? Yeah. Okay. Oh, I didn't need to close that because I might need it again later. Just do high, who cares? Whoa, it literally like left off. It picked up where I left off. All right. Let's see if this works. I was thinking of that question actually, but I think the base VLM would be able to assets. Oh, sorry. I forgot to do that. Evaluate against my benchmark. Yeah, I think the base VLM would be able to answer that question. So it's a good question for like auditing base VLMs. Yeah, look, this one's much better. These results are much better. Oh, well, that one actually didn't outperform the base. It's actually not much, it's not much better actually. Okay, let me see the outputs. Okay, the results. Okay, obviously mine, or the ARGUS was much better. These are both correct. Bro, is my question not hard enough? How did it know there's a cat on the roof? How many kids are hanging on the monkey bars? Dang, bro. The baseline's pretty good. Yeah, we're in this one. It's 305. They're both bad. Whoa, wait a minute. Wait, what happened with this one? Why did this one get it so wrong? Wait, maybe I should be zooming. Maybe I should be zooming the image. You know what I mean? Like scaling up the image until it's the original size. Oh, it is sideways. Wait, why is it sideways? Oh, it is sideways. Wait, what image is this? Image 4. Wait, why is it sideways, bro? Well, 305 is still wrong, right? Yeah, I mean, 305 is still wrong. 305 is still wrong. And it's not sideways. Wait, what? But enhancing. Bro, I can't believe it says 305. Why did it do that? This one says 1010, bro. The baseline actually got it like on the dot. Whatever. Okay, there's another one where baseline outperformed it. There are 6 people in the hot tub? What are we talking about? Oh, this one said 4. No, this one said 5. Why did it say 5? There's not 5 people in the hot tub. If it said 4, that would make sense. There's not 5 people in the hot tub, though. But okay, but these are really good regions of interest, by the way. Just like, Oh, this one's too small. But I guess it's fine. They're both dogs. Yeah, that region of interest is really small. Oh, because it did... Oh. I don't know why it's doing... It's outputting more than one region of interest, even though... Yeah, this region of interest is really good. The helmet appears to be red and white in color, so that's wrong. Wait, bro, why is the baseline answer a higher score than the ARGUS answer when the baseline is wrong? Oh, and this one's wrong too. There is a person sitting on top of the black motorcycle in image 2. Person appears to be wearing a helmet, which is likely black as well. Yo, what is ARGUS talking about? Okay, I'm gonna I'm gonna scale up. Is including the green jet? Yeah, I know. I don't know what it's doing. I don't know why it's doing that, bro. It's actually very upsetting. Which one was that? That was 4? Oh yeah, I don't know why it's including those. But the regions of interest are really good. Like, this is perfect. Single most relevant region is the hot tub. Like, intuitively that should increase the answer, like the performance, but it's not. Okay, the paper, I believe the paper scales up the images. But in any case, like, I'm gonna scale them up. I'm gonna scale it up anyways. Okay, so we'll do this in the crop region of interest. We're just gonna scale it up to the original size. So the cropped is gonna be this. Wait, hold on. Do we want to use the short side or the long side of the image? Hold on. This entire section, 3.2. Wait, did they use the max? on. The V star. So they did re-encoding. Okay, so they did a square padding of cropped regions to the max width and height. Okay, so the width and the height is going to equal crop dot size. Side equals the max of the width and the height. Wait, but this doesn't rescale it upwards. Padded. No, we already do the padding. We already do the padding. Wait. Okay. It's fine. We can pad it. I guess we're padding it again. I guess it should be fine. So this is going to be RGB, side to side, and this is going to be 0, 0, 0. Almost. This is going to be the crop, the side minus the width, and this is going to be, oh, divided by 2. Yeah, there we go. Okay, so now we want to resize. Yeah, we want to resize to give the encoder enough tokens to work with, right? Because if we keep it small, then there's not going to be a lot of tokens. I guess you could do like enhancing or something, but we don't need to do all that. So the target size, we'll just say target equals the min of the image, the original image. Dot size. So this is going to be the min between the width and the height. Rather than treating as new images, resampling you guys. Yeah, okay, I'm not doing that. Okay, target. So if the side is bigger than the target, obviously, or less than the target, then we, if somehow the side is larger than the target, which really doesn't make sense, then we're going to say padded equals padded.resize target, and this is going to be an image. Yeah. And then return padded. Yeah. So this okay, this should work. All right, well, how did I word my results? Let me rename this. This is 1042. Okay, let's try this again. We are padding twice. But I don't know. I don't know. I don't know. It should be fine. Is this for fun? Yeah, it's for fun. Yo, Argus got worse. What? Yo, Argus got worse. What am I doing wrong? What did I do wrong? Okay. It says there's only one kid. Wait, can I see these images? This is image 2. Oh, it's way too zoomed in. It's way too zoomed in. Wait, what? What did I do wrong? Wait, what? Wait, can I see what the region of interest was? Wait, why did it give me this region of interest? Oh, the region of interest is bad on the first one too. It's too small. Okay, maybe this is a prompting thing. Where's Argus? Where's my prompt? Wait, where do I get my cropped thing? You specialize in giving rich regions of interest that encompass the entire relevant section. The entire. You must ensure but minimize non-relevant content. Yo, I'm a GOAT prompter. Yo, I'm actually insanely good at prompting. Yo, let's just delete this result. These results were trash. Yo, I should probably put this in Git because I keep like deleting things and I think I'm like messing up, like accidentally deleting something. Let's make a new repository. ARGUS. It's fine. Create. All right, let's, oh, you know what's gonna happen is that there's a problem. Because this thing is way too large. Visual, way too large. There we go. All right, so can we see what the outputs were like? The outputs were here. And we had hopefully better performance, bro. This is actually kind of making me mad. No, not mad, but like, bro, what is going on? Why is it giving me these trash regions of interest? Like, this would actually be helpful if the region of interest was good. But like, the region of interest is dog. It's so bad. Like, where's the hot tub picture? The hot tub picture had a good region of interest. Like, see this? This is fire. This is fire. Did I get the hot tub picture right? Nah, bro, it still says there's 5. Yo, this is not working. Is because you use light theme. These aren't real glass. Well, they are real glasses, but they're blue light glasses. What's the difference between base answer and baseline answer? What's base answer? What are we saying? Did I have that in my code somewhere? I don't know. Let me see. Dude, I just name variables like whatever's on the top of my head. Oh, this base answer is the like this one. This is the answer without ARGUS. So it's just the VLM. So there's still a ground truth answer that came with the data set. Then there's the base answer that is like ARGUS, or the answer without ARGUS, and then there's ARGUS answer. So this should actually say base answer, not baseline answer, if we wanted to keep consistency. Or actually, no, it says baseline answer here. Yeah, there's no difference. Base answer and baseline are the same thing. I just suck at naming variables. No, you know what makes me mad is when the model does not perform how I expected. Bro, this first image, I was like, dude, ARGUS is like the most genius thing of all time, and it works. Because it did work. Like, look at this, 90 versus 45. What is going on? Why can't I see these images? Hello? Oh, there it is. Oh, maybe because the region of interest is the whole image. You just looked at the image twice. Yo, it's actually tweaking, bro. Alright, the regions of interest are trash. No wonder they trained a model to give good regions of interest. Like, these are trash. This is like the worst region of interest I've ever seen. It didn't even try. Didn't even try. All right. How do I get better regions of interest? I don't really know. Besides for telling the prompts to lock in. Well, I could allow it to give multiple regions of interest. Bro, I just don't like how it didn't listen to me. Hold on, let me try it again. Oops. Let's try it again. Which model are you using for your baseline? Is the same. The baseline is the same model. It's just the model without region of interest sampling and the model with it. I'm using Qwen 2.5 vision language. Yo, Argus, they split. They got the exact same eval. I don't even need to open this. I just need to see the... Yeah, it's like just not listening to me. Yeah, this region of interest is just way too small, bro. I want the whole monkey bars. This one's good. This one is bad. I don't know why it gives me 3 of them. Okay, 6 is good, and I really don't understand what the output is here. Look what it says. It says... Oh, wait, yeah, Argus is right. No, it's completely right. Yeah, blue helmet on a black motorcycle. The baseline's wrong. Look, say it says the helmet appears to be red and white in color. Okay, so like cosine similarity actually doesn't matter. Because like this would say baseline is right, but it's like completely wrong. It's just the difference that makes... Wait, the baseline answer is wrong here too. They appear to be white foxes. Yeah, that's not right. 005. So this is what it looked at and said white foxes. Okay, well one of them is a white dog. The other one's definitely not a white fox. So... You think it's just variability from the... Yo, should I try 32B? I'm gonna try 32B. There's like pretty much no chance that it works. 1057. There's no chance that this loads the entire model. Unless it splits all my GPUs, which is possible. So we'll see if I have to quantize. I mean, it might load, so. Okay, this is just gonna take forever. All right, so I think I only have like an hour till I have to end stream, because I have like so much stuff I have to do today. I just wanted to get this done in the morning. Okay, I'm gonna try the agent approach. Okay, so this approach is much simpler. So essentially, what you're gonna have is a GPT-based agent, right? You're gonna give it a tool. Right, you're gonna have a model, which is GPT-based agent. You're gonna have a tool that's gonna be a CLI tool with pillow and NumPy. So it can segment the image and use that as context. So with agents, there are different considerations that you have to make. So I mean, it's going to be on the order of kilobytes. So actually, we could do it. It's going to limit us to 5 images. But like, this is what we're limited by. GPT API max image count. Um, 10 images. So let's do max 10 iterations. Max 10 iterations. Well, I guess that would be 9 iterations. Like, this is so much simpler. Okay, and I'm actually going to do this using 80K. No, I don't even need to import 80K. But I do need... the docs to install this. This is my favorite agent framework, so that's why I'm using this one. Just move back to base. We don't need to be in a... Okay, actually just stay in Argus. Just one package, bro, who cares? Okay, so there should be like a get started, Python, quick start, root agent, sure. Yeah, we'll just use 80K web just for simplicity, so I don't have to create a runner or anything. Import agent, okay. We're also going to import MLLM. Or light LLM, sorry. Okay, perfect. It's even better. Okay. Requires OpenAI API key. Light LLM. Name, instructions, other parameters. Oh, image segmentation tool. No, just give it a code execution environment. Name. Just name an agent, fine. Root agent. Powered by GPT 4.0 is fine, but we'll just do 5.4. Okay, I need to go. I'll be right back. Okay, I'm back. Alright, so for this one, I'm gonna use 80K just because they manage like everything for you, so it's really easy to use. This is still installing. What the F? This is still also running. What the F again? Okay, we're gonna go to Open Router, to OpenAI, to GPT 5.4. Okay, we got an import function tool, which we do that by going to here, importing this. Okay. Function tool, run code. Oh, it's running. Oh, it's working. Wait, it's actually running? Wait, is it gonna run? Okay, so we have a whatever, however big this is. We have an embedding model and a 32 billion parameter VLM trying to run on my AI server. It's running. That's insane. Yo, 5090 is a beast. Yo, can we see usage, bro? Wait, I forgot how to do it. Wait, it's actually working. The 4090 is full, and the 5090 only has 2 gigabytes left. Bro, it's like, where's the command? Yeah, this one. Yeah. Dude, how is this even running? It's barely running, bro. They're both, bro, you can't see because my camera, hold on. The 4090 is at 23.8 out of 23.9. And the 5090, it's at 30 right now, but it was just at like 31.6. That's insane. It only has 31.8. I don't know how they're how multi-GPU is working. I haven't put in any configuration for multi-GPU. It literally makes no sense. 31.2. Oh, it's 4 gigabytes. We ran out of memory. Yeah. Yeah, we ran out of memory. Let's not load the embedding model. So just go here, embedding model. 0.9. Wait, hold on. No, fine. It's fine. I was going to say if it's whatever, return 0.9. If it's ARGUS, return 0.9. If baseline, return 0. Wow, benchmark confirms my suspicions. Out of memory, bro, what? How? It was just running. I made it smaller. And now it's not working. Tried allocating 1 gigabyte on my 4090. 1.2 is free. Wait, I actually could use that. No, I couldn't. Wait, why doesn't it try both GPUs? Was it trying? Yeah, it's using both GPUs. Oh, this it's running now. 31.1, yeah, no. I was gonna, yeah, it's not gonna work. Okay, it's not gonna work. I can try. This is really stupid. So as I said, my computer is hosting some of my startup's infrastructure, but I could actually kill the process. I could kill the process and yeah, I could kill the process, so and run it just really quickly. I'm just trying to think what happened. Yeah, it seems like something is like people are actually actively using it. Okay, so I'm just gonna try just killing it real quick temporarily. And then I'm gonna test prod, see if production is still working, then so be it. If it's not working, then I can't do this. Let me do this. Let me do this. Let me do this. Yeah, it's failed. Okay. Alright, well, it's killed, so let me just do it real quick. We have like 30 seconds before this needs to be running again. Okay, well, it didn't work. How much is it trying to allocate, bro? There's no way. I can just quantize it. It's not that big of a deal. Yeah, 30 gigs. We're within range. 31. Who killed? For GPU 2? Wait, why is GPU 1 only at... Oh, I guess that makes sense. Okay, we're back. We're back up and running. Okay, good. So let's just not do that anymore. So we can quantize it. I don't really know how to do that. So we'll do FP16. I mean, FP8 is actually kind of like standard. So let's, oh no, we're trying to do minimum lines of code, remember? No, not, we don't need flash attention. We need this. Bits and bytes. Quantization equals bits and bytes, load 8-bit true. Should be fine. Eight bit's pretty small, so what happened? Requires this. Okay, let's do it. That's just so annoying. Okay. Oh, holy slow. All right. So this method, oh yeah, we need the run code tool. So this is gonna look something like this. Let me, this one. Okay. So, wait, what was I doing? I was going to see if this worked. How, bro? Wait, why am I running out of memory on GPT-1 now? Bro, hello? Oh, okay, usage is going up a little bit. But still, bro, the GPU-1 has so much usage left. Bro, why is it not allocating on GPU 0? Should I... Wait, what is it doing? Does it really need both GPUs, yes or no? Probably not. How do I scope the command to just one GPU? It should be like a flag. CUDA visible devices. Okay. Throw this here. Okay, and then wait, I gotta go back to... Okay, I've freed up my 500 megabytes used. Okay, so now I'm gonna try to load the entire thing just on my 5090. This might not work though. What is it saying? Some modules are dispatched on CPU. Make sure you. How big is it? I ran out of memory before. Okay, I guess we have to spill over. What's going on? What happened? What is it doing? Just run it, bro. Like, come on. What are we doing? Obviously, I have no storage. Bro, what is it doing? Like, actually, I'm so serious now. Device map, CUDA, I don't know. Does that work? I don't understand what the difference is. Yeah, like what? Okay, there's no difference based off what happened. Okay, but now it's not spilling over to the other GPU. What is going on? FP32. Wait, why is it loading it in 32? Bro, what is it doing? Wait, let me actually. Alright, this guy will figure this out. In the meantime, let's implement this version. I really have like barely any time left. I need to stop in a second. Okay, well this actually should work. Okay. I have this. This is something that Claude just gave me just now. Okay, so I just need to export. Tab is look-y gonna expose me, bro. Tab is gonna leak me, bro. Okay, let's get an OpenRouter API key. Let's just make a new one, just temporarily. Where's OpenRouter? I don't have OpenRouter as a tab, bro. API keys, bro. Okay, let's just make it temporary. No expiration, 1 hour. Bro, just because I'm on stream, like, I cannot afford any of this getting leaked. Expiration 1 hour, that's fire, bro. Alright, so let's source Zylstra slash dot super secret dot env. Nice. Now let's do Python main.py. Okay, just gotta do this one. Oh my gosh. Okay, okay. So, what did Claude Code say? He said, the problem is to dismiss the model roughly evenly across the GPUs instead of filling GPU 0 first. Also, previous crash runs may have left stale GPU by maximum GPU 1. They've had to remove it. Yeah, do whatever you want, bro. What happened? Is there no main function? Oh, what happened? Didn't do anything. No, just do 80K web. What happened? Oh, already in use. Can I set port? Requires an argument, nice. 8001. Nice. What happened? Oh, just leaked my IP address. What is going on? Why is it saying connection refused? Hello? Why is it saying connection refused, bro? Alright, let's try it again. Alright, wait, hold on. Let me just clear port 8000. I know exactly what's running there. Oh no, it's cursor that's running there. Oh, what a drag. Let's change the port. Port 6969. That's probably the most standard port to use in this situation. What the F, bro? Oh, I'm so stupid. I'm on my server. I need to forward the port. So let me just go here. Oh, I'm gonna leak my public IP address. Let me do it in a different terminal. So let's exit SSH. Well, we could do it over here. It doesn't matter. AI serve space. Let's get our port 6969. And let's get our port 6969. Nice. And so now, to run it. Nice. Okay. Select an agent. Field below agent in the folder that contains the agents. No agents found in current folder. Okay, this is fun. The problem is that we need agent.py from main import agent as this agent equals this, and I think we actually have to put it in a folder, but it's fine. I'll do that later. and then we need an init.py, and it's like, what do I do again? From dot agent. Yes, exactly. That's exactly what we need to do. Okay, now let's do this again. And let's get a window. No agent. Okay, yeah, we have to put in a folder. Agent. No. Test. Move. From dot. I mean, this should work. There. Test. Hello. Let's stream it. No, did not work. From main failed to import test module attempted relative import beyond top level package. Oh, so annoying. You know who is really good at fixing these kinds of things? Is the agent. Okay, go ahead and fix that for me. Go ahead and fix this for me. I have a Slack message. Okay, responded to Slack. What did it do? He said this. Okay. So all I had to do was that, apparently. Let's reload this. Let's say token streaming. Let's say hey. It's loading, and we got another error. It says authentication error. No cookie auth credential found. All right, that just means I need to pass the API key somehow, somewhere. So we need to pass the API key using this API key and pass it like this. Hold on. Oh no, we don't pass it anywhere. Wait, why is the API key not working? Let me go over here. Make sure we don't leak my entire life. I sourced this whatever. Oh yeah, nano super secret.env. Let's do that. That sounds like a great idea on stream. Yeah, still getting the error. So for some reason it's not working. What happened with this one? Did I run this? What did it say? Yeah, it still didn't work, bro. Okay, this is what it says to do for this one. Okay, and if I say hi, okay, nice, it works. Okay, so let's give it an image. Let's give it, which image do we want to give it? Let's go ahead and give it, which one did it struggle with? The monkey bars one, it struggled with a lot. So let me close this thing. Where's the monkey bars image? This one. Download. 3.png, and what was the question? How many kids are there on the monkey bars? Okay, this one is going to be a little bit more difficult to benchmark, but we can test to see if it works. Oh my gosh. No such file or directory. What is it saying, no such file? Oh, wait, what? No such file. Is it saving the image? Wait, hold on, let me see. Oh, you know what I should do? Wait, let me read this again. Okay, that's why. All right, so let me make a new session. Just copy from the benchmark. It's going to provide its own. Oh, shoot. Okay, you're right. You're right. This is going to be, let me copy the absolute path. Okay. Now, the moment of the real moment of truth. Okay, loaded the image. Now, another bad. This endpoint's maximum content length is 128,000 tokens. 219,000 tokens? Yeah, right. All right, wait, what? Wait, what is it doing? How is it passing the image? Yo, we're tweaking, though. Yo, it's tweaking. Yeah, let's go ahead and wait, how do we do the images over here? I really do have to end stream in 20 minutes though. Like I have no choice. It's very unfortunate that this 32 billion parameter model is not loading. GPUs are mostly clean. The real issue estimates model size. 64 gigabytes? 52 gigabytes? So it dispatches models as CPUs. Heap it rejects. Huh. Okay. I don't know what it's talking about, but my solution, if it was me writing the code, I would have just did 4-bit quantization. But you know, we can lie to Torch and tell it that we have 50 gigabytes of VRAM on one of our GPUs. Whatever you want. Yeah, out of memory. Yeah, I told you. I'm wasting water by making Claude Code do that. I could do that in like 3 seconds. Hold on, I'm figuring out. Alright, I'm ending stream in 17 minutes, but okay. Dude, why do I have work to do now? Slack is my least favorite app. No, but I can't do work until after this thing anyways. So I got Argus working. We're telling it to do 4 bits. The results were good on some of the images, but some of the other ones were not so good. So I would say successful. Somewhat successful. Yeah, okay, we can't run the 32 billion parameter model. It's just not possible. I guess it's just trying to use too much compute. Wait, how is GPU 0 running out? Wait, yeah, are we not understanding? Did we not see what I'm saying? How is 0 ever running out? That doesn't make sense. 0 can't run out because we're only using 0. Oh, did he not change the 50 back? No, he did. Yeah, he removed everything. So what is going on? Sequential. Should it be auto? I don't know what sequential means. What does sequential mean? Is that really even a type? Yeah, I should just use auto, right? Max memory. Okay, now it's just making stuff up again. Let me just do auto. Auto should work. If auto runs out, then we know. Okay, it ran out. Is it filling 0 though? The problem is it's not filling 0, it's just hitting 1. Yeah, I don't think you can do this in CUDA like without actually touching like real stuff. Yeah, so I think if I wanted to continue this, I would try to improve the bounding box detection, because that was really the main, or not detection, but the bounding box generation, because I think that was the main bottleneck. Like, this region of interest, not helpful at all. I don't even know what this region of interest is. Yeah, this also is not helpful. See, this is a good example. The cat, like I asked it what animal is on the roof, it should have just done the whole roof, right? It should have made a bounding box around the entire roof. But instead it made a bounding box like here. This one was the worst one. I asked it, who's on the monkey bars or whatever, and it made a bounding box. You can't see it because all this stuff's over it, but the monkey bars are this whole area. And it just did like this for some reason. I mean, I guess I can, okay, let me try to edit the prompt on another time. Just like actually, okay. Okay. So I edited the prompt. So let me go back to loading. Let's do this. Let's get the 7B again. And let's run this again. This is running my benchmark, right? Yeah. Okay. Get some answers here. So can we see the region of interest? Nah. Yeah, see, so it's just like not listening to me. I don't know what these regions of interest are. I told it to output 1 region of interest. Sometimes it does 2. Like, this one's good, but that's it. This one's also good. This is terrible. I don't even know why it's outputting bounding boxes for these images. So it's like just not listening really. So maybe the bounding box generation is kind of not even our limiting factor though. Because if we look here for like image, which one was good? I think it was 4. The 4 is the hot tub. Yeah, so like this is a great bounding box, right? It's perfect. It gives us the hot tub, and so it can definitely answer the question. The question is, how many people are in the hot tub, right? The answer is obviously 3 people, and then I don't know what this even is. So I would allow 4, because that's like an intuitive mistake, right? But it says 5 people in the hot tub, shown in image 2. And that doesn't make sense, right? There's not 5 people. So I think that kind of proves that, you know, this base model is not really that strong. I mean, it doesn't prove it without a shred of a doubt. And it also doesn't mean that that's the only reason that this approach is not working. But if we had a stronger... Okay, the problem with like trying to go to APIs is that I don't know APIs that output bounding boxes as well. Let me see. I also have 8 minutes until I need to leave. I actually need to leave. Qwen VL. No, just search. Is there like a useful text search? Qwen VL. Isn't there like a... Hold on, I had it pulled up earlier. Yeah. So they have 32B, 72B. Like those won't fit on my setup. Should I buy another GPU? Like I could. Let me see if I can get Qwen VL 72B, like an API. It's accessible via several third-party API providers and can also be run locally. Okay, Qwen provides an API. 3 VL plus. That looks good. Do you think it has bounding boxes though? Thinking. Wow. OpenAI SDK. Everyone uses the OpenAI SDK. So okay, here we can try it. Okay. Wait, let me just copy the system instructions. See if this one will listen to me. The question is monkey bars. Okay, let's see if it can output. Bro. China is trying to steal my identity for me to use this. Are we serious? So I can't even use it. Oh, look, wait, it's on OpenRouter. Wait, it's actually on OpenRouter. Oh my gosh. Wait, bet. Wait a minute. I can actually use OpenRouter. Wait, bet. Yeah, I can use OpenRouter. Can we get Claude to do this for me, please? No, just be quiet. Okay, Claude, really quickly before I leave. Oops. Oh, yeah. OpenAI Python. Oh, it might need a image URL. But actually the docs say that you can use image base 64. Yeah. So let's give it this one. Okay. So I'm making it write a new function, so that's why I don't care if it touches this code. Otherwise, I really wouldn't want it messing with my code because I actually wrote this by hand. But let me first read the existing file. Good job. Okay, this actually probably could be finished in 2 minutes. I have tons of emails, bro. Why are people emailing me? For what reason? I need to submit my timesheet, that's true. Oh, they canceled our meeting this morning? Yeah, I forgot it. I wasn't even gonna join. Totally forgot about it. It was obviously this morning and it's past this morning. Okay. Yeah, I gotta do that at some point. Otherwise, wait, can Claude make sure it doesn't leak my API keys? Because it's actually very important. He's gonna be like, oh, I noticed I can't find your API key. Let me search for all .m's on your computer and print them all to console. No, I wouldn't do that. What's up, SB? What's up, Alex P? What is the focus of this? I'm implementing a paper. First time I caught you on live, that's fire. Yeah, holy crap, look at all this code. Okay, good though. It added like a comment. So 326. 326. Claude generated API version. Done. Here's what I added. Okay, main. I don't know, the only reason I'm using Qwen is I don't know any other VLMs that support bounding boxes. 72B or 2.5 definitely does, so 72B is the biggest I could find. What is this? Evaluate my benchmark API. Okay, sure, allow it. Evaluate my benchmark API. Let's go ahead and move this up here. There. And okay, let's see if this works. Let's source this one, and let's do Python named up here. Why is it loading the model still? Wait, hold on. Let me kill this and, oh, it already says API. Oh no, the region of interest is even worse. Okay, it's fine, because the padding worked. The region of interest is worse, bro. How does 72 give a worse one? At least the baseline works. At least it's like intuitive. The baseline actually is like bad. Okay, let's see. Yeah, see, this is much better. Look at the roof. Okay, the padded is not really helpful. The padding is too much. There's too much padding. But this roof one is like much better. Look at that. Yeah, the monkey bars now. Look at this region of interest. Much, much better. You can clearly see there's two kids on the monkey bars. What is that one? Which one was that again? Okay, this is terrible. I don't know what this is. Yeah, Argus, they must have done something good to get like some strong regions of interest. Wait, I keep losing what image I was on. This is 2? Yeah, 2. After carefully examining both images, I can identify 3 kids hanging on the monkey bars. No. Holy verbose, dude. Like, what? Yeah, it's still wrong. It's still wrong. There's 2 kids, but 3 is acceptable because like there's this girl here, kind of. Yeah, these bounding boxes are trash. Wait, 4? What did I ask in 4? 004. How many people are in the hot tub? This is even worse. This is worse bounding box. Yo, this is worse than 8B. The bounding box is worse than 8B. Yeah, these bounding boxes are trash. Okay, there is a consideration though with the API. Legitimately though, with the API, I don't know what the bounding box outputs are. I mean, intuitively you'd think they're the same. And also Claude generated all this code. I really don't know what he did. So I wouldn't trust it too much. I will, like in the future, I should actually do this. Try the API, like actually write real code that can try the API and look into how it outputs bounding boxes and stuff like that. So, I mean, it's successful enough. I wouldn't say it was like an overwhelming success, but it's successful enough for me to call it a day, I think. So like I implemented ARGUS with the goal to set out to prove that allowing the VLM to see or to first find regions of interest and then look at those expanded regions of interest in context could improve the underlying VLM's performance. I mean, this is like a benchmark I created myself, right? So it's not really a good benchmark. But at first, I was like, wow, this is really working. Like, if we see one of these, like, no, not this benchmark. If we go to this one, like number one, this is like overwhelming. I was like, holy crap, it works, right? The ground truth, the majority of people on the patio are wearing black. ARGUS answered the majority of people on the patio in image one appear to be wearing black. That's insanely good performance, right? The original image was this image. If I can find my benchmark, this is image one. It's this image, right? Very complicated. There's one patio. Ideally, region of interest would be just the patio, and then it gets to look at just the patio by itself. So like that was really promising, and we saw the baseline gave like the really like a really bad result. The majority of people on the sidewalk, don't know why it's talking about a sidewalk, are wearing various colors, diverse, whatever. I don't know what it's even talking about. So that was like, wow, this is promising. This is great. But then after further evaluation, I realized that the underlying model was just not strong enough to reliably test using my benchmark. With such few examples, like if I had 10,000 examples, we could kind of develop a pattern of better performance and say maybe, like the underlying model's performance does affect it, but every 1 in 100, it actually is able to give a good result. So we can see that it does, in fact, outperform the baseline. But I wasn't able to get the better model loaded on my personal AI server. And then I tried to use the API. Results were bad. So I'm jumping to the conclusion that I don't know how to use an interface with the API. And also Claude generated this code, so it's probably just terrible. As we see, like some of the bounding boxes are fine, but a lot of them are bad. Like this one, I asked it what time is it, right? And so if we go to my implementation, the bounding box it gave us, this is image 3, is like directly around the clock. Like this is an example of a great bounding box. And so this would yield a better answer more intuitively, right? This is the image that's given in context, right? If you ask an LLM, what time is it? And they just see this, or not an LLM, a multimodal LLM, and they just see this image intuitively, you'd be like, okay, they could probably tell you what time it is. Might be hard for them. They just need a really strong attention mechanism. But if you give this image as context, so you have 2 images and you ask it what time it is, it's much easier for its attention to work correctly and diagnose the time. It doesn't have to diagnose both where the clock is and the time. It already did where the clock is in the first pass, and now it just has to figure out the time. However, the output did not support that even. Right, here is it. Here's the one. It's like, what time is it? The ARGUS answer, the time is shown is 10:10. Okay, actually, this one is fine. 10:10, that's correct. So I did see in one of them, it said like 3:40 or something, or 3:15, which was bad. But yeah, I mean, this one gives 10:10, but look, the base model also gives 10:10, so it's like, oh wow, the attention mechanism is pretty strong. But then some of them are just bad. Like this one, hot tub, there's clearly 3 people in the hot tub. Do great region of interest. But for some reason it says there's 6 people. And the baseline also says 6 people. 6 doesn't even make sense. I've seen it say 5 sometimes. 6 literally, like there's not even 6 things in the image that could possibly be a person, right? There's 4 at most, right? Or I guess 5 if you really want to like say this could be someone's head or something. So 6 doesn't really make any sense. And it's a great bounding box. So that leads me to believe like the base model is just too weak. Because this is like, I mean, any VLM given this picture can tell you how many are in the hot tub, regardless of if they need region of interest or not. Like if you just give them the region of interest, they will be able to tell you the answer. And then some pictures like these, like the bounding boxes are not good, right? We want all the pumpkins to be in the bounding box. It just did these. There was another one. There's a better example. This is a good bounding box, actually. And this one actually gave me good answers every single time, right? There's what is the color of the helmet on top of the motorcycle? The answer is blue helmet. The object on top of the motorcycle appears to be a helmet, which is blue in color. Perfect. The black motorcycle has a helmet placed on top of it. So it did get this right, the baseline, but it got the color wrong, which makes sense. Like if you think about an attention mechanism, like intuitively, especially for a weaker model, you'd be like, okay, you know, it can weight like the attention on this area of the image higher, but is it going to be able to just like auto-regressively, or I guess limited by its auto-regressiveness, and without any sort of reasoning or thinking, is it going to be able to diagnose both where in the image it should be looking and then also what color the helmet is? And you know, the intuitive answer is no, and that's what happened, right? So the region of interest was able to give the right answer, but not the baseline, which is good. But like the most alarming one, or not alarming, but the most frustrating one, okay, this one was pretty frustrating as well. What animal is on the roof? Right? This bounding box is terrible. We want the entire, like, if you think, like, as a human, okay, how would we make a bounding box to figure out what animal's on the roof? We would make a bounding box around the entire roof, right? If you make a bounding box on what you think is a animal at first glance, right, you risk overfitting and also missing data, right? So this bounding box ends up not being helpful at all, and I actually think it would make the result worse. Same thing with this bounding box here. The question was how many people are swinging on the monkey bars, and there's 2 people. You could see it if these things weren't here, but it ends up zooming in on just like one specific area of the monkey bars, and you can see that. You know, if it zoomed out a little bit, it could see the other person on the monkey bars. So that is like points me to believe that the underlying model is not strong enough, especially for creating the regions of interest. Because we see like when the regions of interest are good, like the answers are as we expect, right? I mean, this hot tub one is an anomaly. I really don't understand that. And so that's why I also believe the base model has some effect on it as well. So if I were to continue this, which I might someday, I would try to figure out how to get a better underlying model and maybe better bounding boxes. I mean, in the ARGUS paper, they like actually did a full training. I'm pretty sure they had an A100 or an H100, so they had much more compute than I have. But they were able to train both the bounding box creation and then also just like the underlying VLM to be much stronger. They might have used a pre-trained VLM, I don't know. I don't remember, at least. Yeah, I mean, the region of interest is really the most important part, because if you can get a good region of interest, it doesn't matter what the VLM, the downstream VLM is. I can pass it to like GPT API or something and get a behemoth VLM or multimodal LLM. So the real limiting factor in my implementation is the ability to get strong boxes. And I didn't try that, actually. That's a good idea. I imagine I would see better performance even with my implementation that we have now if we just used a stronger VLM in the re-engagement, right? So when we send the region of interest and the original image back to the VLM, if we used a stronger VLM, that could reason around poor cropping, and some of these like the hot tub one. I mean, there's literally no way. I mean, we can just test it. Look, I'll just do it. Let me I'll just do it, because I know it literally never got this right, not one single time. So it never got the hot tub question right ever. Let me do the hot tub. Where's the hot tub? Oh, this one gave bad result. Yeah, this is the API. Hold on. Where's the hot tub? So these two are the hot tub and the hot tub region of interest. Let's download them. Oh, download. And let's go to GPT. Let's put them in. And let's just ask the question. You would maybe need like a base prompt here. It's fine. Based on the image and the sampled region of interest, answer the following. How many people are in the hot tub? Okay. I don't know what this working is. I don't know what it's doing. I don't know what it's doing. Because sometimes it will run code and look at the image. Yeah, there are 3 people in the hot tub. Total people in the hot tub, 3. Right, so we get a great response, and I mean, we can intuitively see that the region of interest would be helpful. But you know what? I'll actually say how many people are in the hot tub, and I'll give it the original image, which is this image. I don't know what this path is. I don't know what this path is, but let's try it without running code. Or doing anything other than looking at the image. Answer this. Okay, the reason that I say all these words is because GPT does have underlying frameworks that allow the model to enter thinking mode and then like iteratively analyze the image, which is exactly what we're trying to do with the region of interest. And I'm skeptical on what working means. I think they're doing something like that. So if it gives the right answer, I'm really skeptical about this working thing. Because it usually says working when it's running something, like it's agentically doing something. So I think it's lying to me. Yeah, it's 3 people in the hot tub. I don't know what the working was, but I got the answer right, actually, so this doesn't prove anything. Didn't prove anything. I didn't prove anything. Why was it working for so long, bro? Okay, but look, if I give it the prompt, look, this is why I'm skeptical, because wait, it's not letting me see it. Yeah, I don't know what this working is. It's obviously not analyzing the image, right? We can agree that it's doing something fishy behind the hood, under the hood. So I'm actually going to try on OpenRouter. Let me go to chat, and let me just get GPT. Anyone, it doesn't matter. Okay, wait, that's actually the right image. Okay, this is actually more, this will be more representative, because this is actually a direct API call. How many people are in the hot tub? There are 4 people. Okay, see, this is what I'm saying. I don't know what OpenAI does. Oh, look, this one also says 4 people. Huh, very strange. Okay, so wait, let me move my face. This is a perfect example, actually. I was skeptical, but now it's working. So it says 4 people, right? I gave it just this image, right? If I create a new chat somehow, like this, and I give it both the image and the region of interest, and I say, how many people are in the hot tub? I'm not even gonna give it a prompt. I'm not even gonna tell it to look at the region of interest. I'm just gonna upload it and see 3 people. Perfect, bro. Exactly what I was trying to prove. And you can do this like a bunch of times. Like, look, I'll do it again. I'll do the exact same thing that I just did again. This proves exactly, I think, what I wanted to prove. Look, 4 people, it says 4. Clear as day. We just tried it again, it says 4. We give it the image and the region of interest, and it says 3 because it is 3. That's correct, 3. Yeah. So this kind of, I mean, it's obviously not very rigorous, but this proves that, you know, the region of interest actually can substantially impact responses. So not only is region of interest sampling very, very important, and one of the drawbacks of my implementation, because the underlying model was honestly terrible at creating regions of interest in some images, but also the results were heavily influenced by the base model's capabilities. Like when I was asking just Qwen, the normal Qwen, these responses were just terrible. Even with the region of interest, it didn't give good responses. So increasing the size of both models would probably yield comparable to ARGUS results. I mean, overall, I actually am kind of, this GPT thing that I just did was really helpful. It makes me more optimistic about this implementation, and that the base model was really my problem. So I might buy another GPU. If I buy another GPU, then I can run like a 72 billion parameter or even larger. It's just I gotta look at how much money GPUs are these days. But yeah, that's it. I gotta leave for real now. I'm way over time. I didn't even get to implement this solution, this one, but I am going to implement it outside of this, right? Because I need it for a project. So we'll see this. We'll see this like actually work in real life at some point once I develop it. And then I also need to do research onto other things. I think my next thing that I'm going to do is build a VLM from scratch. So a VLM, a vision language model from scratch. Not ARGUS from scratch, like an actual VLM. I think I'm gonna use Lava or something, just like one of the older VLMs. The problem, the only reason I haven't done that yet is because they're huge. Like not, like an 8 billion parameter or 7 billion parameter VLA or VLM would be fine, like running inference. Inference is relatively cheap, but training a VLM on my setup would take a very, very long time, especially a 7 billion parameter. And then also I would risk running out of memory, although training is a little bit easier to not run out of memory. I mean, you might run out of memory at the end of training, but you could just use like one of the checkpoints. And then there's a bunch of memory optimization you can do during training. But with inference, if you don't have like mixture of experts, which I don't, like I could like try to figure out. No, I mean, we'd have to retrain. Like without mixture of experts, it's really hard to optimize inference, right? The best way to optimize inference is to reduce the amount of active parameters during inference, but using a pre-trained model, you can't really do that. So the next best thing is quantization, which I did. I did 4-bit and 8-bit, but it still wasn't enough to fit these bigger models onto my setup. What app do you use for your Mac so you can see the CPU, GPU, and RAM? This is just called Stats. It's an app called Stats. Let me see. It's just called Stats. That's it. I don't know what else. I don't know how to show it, but it's called Stats. Pretty sure it's on the App Store. I'm pretty sure that's where I got it from. No. This is a copy of it, State. But it's called Stats. Hold on. Yeah, this is it. This is it. Mac Stats. But I'm really optimistic about what ARGUS and the whole like region of interest, chain of thought approach to reasoning. I'm really optimistic about it. Another thing that I wanted to do was implement this paper. This one. Yes. I don't think the code was open sourced. So I really wanted to do this one. The problem with this one is it's a VLA, so it's obviously going to require much, much more compute. VLAs are pretty big. You're gonna, because I'm gonna have, it's just and it's just larger than a VLM. It's the same thing as if I had a VLM but larger, right? So I have some underlying LLM, some vision encoder, and then on top of that, a diffusion model for action outputs. Well, it actually could be something other than a diffusion model, but GRUT and similar models use diffusion. And then running reinforcement learning on top of that, that would really happen during training. So, I guess this is continual learning, so it would actually happen at inference as well. I actually have to look at this paper because I want to see. I don't think it's really continual learning. I think it's misleading. I think they're just doing normal learning, but they're making the reinforcement learning so cheap that you can afford to do it often. Because transformer models as a whole cannot be trained while running inference. And so that's one of the biggest, like architecturally, you can't do gradient descent while also running inference. So that's actually one of the reasons that continual learning is so hard, is because the brain, like we are learning as we're thinking. But an LLM or any transformer model, architecturally, like fundamentally, is limited by one or the other. They can't be doing both at the same time. You can't do gradient descent and run inference at the same time. It just doesn't. It does not work. It's not even that it doesn't work. It's not possible. I'm gonna hop off. Yeah, me too. All right, I'm leaving. Goodbye. I'm really late.